In this video, we are going to learn how to identify the families of functions, describe transformations of parent functions, and find the domain and range of the graph. Okay, so let's start first with the parent functions. So the first one is the constant, which is f of x is equal to 1. So if you can see, the graph is in horizontal line. The next one is the linear function, which is f of x is equal to x. So you can see that the graph is in diagonal. Okay, the next one is the absolute value function, which is f of x is equal to the absolute value of x. If you can see, the graph is in V form. And the last one is the quadratic function, which is f of x is equal to x squared, which you can see that the graph is a curve and it is upside, going up or facing up. The opening is upside, going up. Now, if we are going to give let's give the range and the domain of this graph. So for when we say domain, it is the value of x. So for the constant, for that graph, the domain starts from, we have from negative infinity to positive infinity. Okay, and then the range, range is the y, the value of the y. So it is equal to 1. Okay, for the linear function, the domain, if you can see the domain, it is represented by arrow going to the left and going to the right. So that means that our we have from negative infinity to positive infinity. And for our range, we're looking for the y-axis or the y, so the value of y. So it is from negative infinity to positive infinity. Okay, for our absolute value function, the domain is, if you can see, we start from negative infinity going to positive infinity. And for our range, we start from 0, so 0 to going up, so it's continuous, it is positive infinity. But for the 0, we have to include it. Okay, we start from 0, so it must be closed there, and then the other side should be open. Okay, and for the quadratic, the domain, so we're looking for the x-axis, so from negative infinity to positive infinity. And then our range is, we start from from 0 to positive infinity. But this side should be closed because we include the 0. Okay, now let's proceed to the next. Okay, so this time we are going to identify a function family. So in this case, since the graph is v, so therefore the graph of f is v-shaped, so f is an absolute value function. So this one, it is an absolute value function. Okay, now if we are going to describe the transformation, so if we can see, so the parent function is here. So if we are going to describe it, so what happened is that um, the graph is shifted up and it is narrower than the graph of the parent function. So we have the graph is shifted no, up and it is narrower than the parent absolute value function. Okay, let's proceed to the next one. Now, describing transformation. So a transformation changes the size, shape, position, or orientation of a graph. A translation is a transformation that shifts a graph horizontally and or vertically but does not change its size, shape, or orientation. So let's look at the example here. Graphing and describing translations. So let's graph g of x is equal to x minus 4 and its parent functions, then describe the transformation. So if you can see, there is already the parent function in here. Okay, so this one is the parent function is named as f of x is equal to x. So this parent function is f of x is equal to x. Okay, now so our task now is to graph the g of x is equal to x minus 4. So first we have to look at or get the slope. So since we see here, okay, there is no number here, so that means that there is an imaginary number, okay, which is 1. So that is the slope. So that slope is 1 over 1. Okay, remember the slope is rise over run. Okay, and then our y-intercept is negative 4. So y-intercept means where the line crosses in the y-axis. So to graph it, we have to look at first the y-intercept. So the y-intercept is somewhere here. Okay, so the y-intercept is somewhere here. So that is negative 4. And then it says the slope is 1 rise and 1 run. So 1, 1. So the next that is there. Again, 1 rise, 1, 1. So that is there. Then 1, and then 1. And then 1 up, and then 1 to the right. Okay, and then when we have to connect, okay, the dots to form the graph. Okay, so this one now is, okay, g of x is equal to x minus 4. Now, if we are going to describe the transformation, so this one is a transformation which is, it goes, okay, so from here, so it goes down by how many? 1, 2, 3, 4. So it is 4. So meaning to say that, okay, the graph is, okay, the graph G is, okay, 4 units down. Okay, so that is our solution. This is our solution. So the solution is the graph G is 4 units down. Okay, now the next one, example number 3, graphing and describing reflections. So graph P of x is equal to negative x squared and its parent functions, and then describe the transformation. So if you can see, this graph is obviously, or this function is obviously a quadratic function. Okay. So what we need to do, since the parent function is already there, so we will just graph, okay, the p of x is equal to negative x squared. So in this case, we will be needing a table, okay, so that we will know the value, okay, or the coordinates or pair of numbers. Okay, so so we have here the first column is the x. So let's say the value of x we will have here 0, okay, this one negative 1, negative 2, and this one is 1 and 2. Okay, now, so we are going to find the value. Okay, so if x, okay, is negative 2, okay, so y would be, we have y is equal to negative times negative 2 square it is equal to negative 2 squared is 4 times negative is negative 4. Okay, next one, y is equal to negative, and then substitute the value of x, which is negative 1, square it is equal to, so negative 1 squared is equal to 1 times negative is negative 1. Okay, so if y, okay, negative, and then if the value of x is 0, square it. So 0 squared is 0 times negative 1 is 0. Okay, and then we have here y is equal to, we have negative, and then the value of x is 1, square it. So 1 squared is 1 times negative is negative 1. So we have here y is equal to, we have negative times the value of x, which is 2 this time, square it is equal to, we have 2 squared is 4 times negative is negative 4. Okay, now, so we have now the pair, okay, pairs of numbers. Okay, so let's now plot it. So if x is negative, okay, negative 2 and then negative 4, so negative 2 going down, negative 4 is here. Next one is negative 1 and negative 1. Negative 1 and negative 1 is here. And then we have 0 and 0 is here. And then we have 1 and negative 1, 1 and negative 1 is here. And then 2 and negative 4. So 2 and negative 4 is here. Okay, now then we have to draw the graph, the curve. Okay, so if you can see our parent function, okay, if you can see our parent function, okay, is being reflected, okay, in the y-axis. Okay, so therefore we can say that, okay, okay, so solution, okay, the graph of p, okay, is the graph of the parent function flip over the x-axis. Okay, so the graph of p is the graph of the parent function flipped. Okay, the x-axis, okay, x-axis. Okay, now can we give the range and the domain of this p of function p of x is equal to negative x squared? Okay, so this one. So let us first name, okay, p of x is equal to negative x squared. So if you can see, guys, okay, the parent function, if there is a negative here, okay, so it is being flipped. Okay, the reflection is the opposite. Okay, it will be a reflection. Okay, now the opening is upside down. Okay, so let us give the domain. So the domain is, okay, so it has negative infinity to positive infinity, and it is all open. What? Okay, so the range is, okay, the lowest is negative infinity. We have negative infinity until 0, and then it is closed. Okay, next. Okay, let's proceed to the next one. Graphing and describing stretch and shrinks. Okay, this is stretches and shrink. Stretches, okay, and shrinks. Okay, so graph g of x is equal to 2 times the absolute value of x, and its parent functions, and then describe the transformation. So we don't need to worry about the parent function because it is already there. So what we need to do now is to graph the g of x is equal to 2 times the absolute value of x. So first we have to fill up the table again. So we start here from 0, negative 1, negative 2, and then 1 and 2. Okay, then we have to, okay, find the value of y. So y is equal to, okay, 2 times, okay, the absolute value of negative 2 is 2. 2 times 2 is equal to 4. Okay, then we have here y is equal to 2 times the absolute value of 1. Okay, so absolute value of negative 1 is 1 times 2 is equal to 2. And then we have here y is equal to 2 times the absolute value of 0. So absolute value of 0 is 0 times 2 is 0. And then y is equal to 2 times the absolute value of 1 is 1 times 2 is 2. And then we have y is equal to 2 times the absolute value of 2 is 2 times 2 is equal to 4. So we have pairs of numbers now. So our x is negative 2 and the y is 4. So negative 2 and, okay, let's use another color. Okay, so negative 2 and 4 is here. Negative 2 and 4. Negative 2 and 4 is here. Okay, then we have negative 1, okay, negative 1 and 2. Negative 1 and 2 is here, and the other one is 0 and 0 is here. And we have 1 and 2. 1 and 2 is here. And then we have 2 and 4. 2 and 4 is here. Okay, so we can now draw, okay, using another color. So I will connect this one using a ruler. We have to connect this. Okay, so that's it. Now can we describe now? Okay, so the y coordinate of its point of G is 2 times the y coordinates of the corresponding point on the parent function. So we have, okay, let's have our solution. Okay, we can say the graph g of x is equal to absolute value of x. Okay, so we have, okay, the graph of g of x equals to, okay, times the absolute value of x, it, okay, is a vertical stretch of the graph of the parent function. Okay, that's it. Now, let's proceed to the next one. Okay, so example number 4, graphing and describing reflection. So graph h of x is equal to 1/2 x squared and its parent functions, then describe the transformation. So we can see the parent function is already there, so we don't need to graph it. Okay, it was already given in there. So the only thing that we are going to graph is the given, which is h of x is equal to 1/2 x squared. Okay, so let's again, okay, do the table. Okay, so we have here 0, -1, -2, and then we have here 1 and 2. Okay, now let's find the value of y. If, okay, x is -2, so y is equal to 1/2. Is it 1/2? Okay, yeah, 1/2 times the value of x is now -2, square it. Okay, so when we have -2 squared is 4, half of 4 is 2. So next, y is equal to 1/2 times -1, okay, and then square it. So -1 squared is equal to 1. 1 times 1/2 is 1/2. Okay, next we have y is equal to 1/2 times, okay, 0, okay, square it is equal to, so 0, okay, okay, squared is 0, half of it is 0. Okay, then we have y is equal to 1/2, okay, and then times the quantity 1 squared it, so 1 squared is 1, okay, times 1/2 is 1/2. Okay, and then we have y is equal to 1/2 times, okay, 2, and then squared it. So 2 squared is 4 times half is 2. Okay, now we can now graph, okay, our coordinates. So we have first coordinates is -2 and 2. -2 and 2 is somewhere here. -2 and 2 is somewhere here. Okay, the next one, -1 and 1/2. -1 and 1/2 is somewhere here. Okay, and then we have 0 and 0 is here. Okay, and then the other one, we have 1 and 1/2. 1 and 1/2 is here. And then the other one is 2 and 2. 2 and 2 is here. Okay, now let us draw the graph. Okay. Okay, so let us name this graph as h of x is equal to 1/2, okay, x squared. Okay, now, so if we can see, okay, so the graph of h of x is equal to 1/2 x squared is a vertical shrink of the graph of the parent function or parent quadratic function. Okay, so our solution here, okay, the graph, okay, of h of x equals 1/2 x squared is a vertical shrink, okay, of the graph, okay, of the parent quadratic function. Okay, now can we give our domain? Okay, so let's use D for domain. Okay, domain. Okay, we're giving the domain of the of h of x is equal to 1/2 x squared. So we can see, okay, the x-axis. So the value of x we start from negative infinity to positive infinity, and it is open because it is continuous. Okay, for our range, okay, we're going to look at the y axis. So we started from 0, okay, and then going up, so it is an infinity. So here it is closed and this one is open. Okay, next, do we still have one? Oh, no more. Okay, so we have everything already. That's it.